Good morning, friends. So today we are going to discuss factors affecting rate of corrosion. So there are two factors. That is, first is nature of metal, and second is nature of environment. So let us see first factor, that is nature of metal. So generally there is a question in the exam, that is uh, explain factors affecting rate of corrosion. So if the question is asked like that, explain factors affecting corrosion, so you are supposed to write, means you are free to write any of the factor. But if the question is asked like nature of the metal, you are supposed to write only the factors which is present below the nature of the metal. And if there is a question like nature of the environment, so you are write only nature of the environment. The first factor is nature of the metal, that is position of the metal in the galvanic series. So as I earlier told, that is the metal present or having higher position in the galvanic series will undergo corrosion. Second thing, the metal which is present at the bottom of the series will be protected from the corrosion. One more thing, if there is more difference between the two metals connected, there will be faster corrosion. And second is hydrogen ore voltage. So it is inversely proportional to the rate of the corrosion. So as hydrogen ore voltage is more, there will be less corrosion, and vice versa. So for example, high hydrogen ore voltage of zinc, that is 0.76 volt, shows the rate of corrosion. But if uh, addition of few drops of copper sulfate takes place, that will accelerate the corrosion due to reduction of hydrogen ore voltage to 0.34. So means 0.76 is the initial hydrogen ore voltage, and if few drops of copper sulfate is added, then that hydrogen ore voltage is converted to 0.34. And if few drops of platinum chloride is added, then that hydrogen ore voltage is going to reduce to 0.2 volt. That means there is faster corrosion. Next, purity of the metal. So pure metal is resistant to corrosion, and if impurity is present, then the galvanic cell is formed. And again, the galvanic cell, the anode is depend on the galvanic series. Next is presence of, sorry, relative areas of anode and cathode. So if the area of the cathode is more, then it will demand more electrons. That means there will be faster corrosion at anode. So smaller the area of anode compared to cathode lead to the faster corrosion at anode. Next is physical state of the metal. So smaller granule metal will corrode faster than larger metal. All the type of the structure formed by the metal will have effect on the corrosion rate. A bent metal is rapidly corroded due to stress. So smaller size metal will get corroded fast as compared to larger size metal. And last is, sixth one is nature of oxide film. So porous oxide film will be non-protective, and non-porous oxide film will be protective oxide film. So you can see the example. If the volume of the metal oxide is more than the volume of metal, the specific volume ratios of nickel, chromium and tungsten is given 1.6 to 3.6. Least corrosion or no further corrosion occurs. That is depending upon the peeling bedwork rule. And second factor is nature of environment. That is, first is temperature. So as temperature increases, that means that ions present in the electrolyte will get kinetic energy and it will move faster, and there will be fast corrosion. So as temperature increases, rate of corrosion also increases. Second, humidity or moisture. So presence of moisture increases or accelerates the rate of corrosion, as it is acting as a electrolyte or conducting medium. Third one is pH value. So don't write like this, as pH increases, corrosion increases. So you remember, low pH means acidic, high pH means basic, That means at acidic and basic pH, both corrosion occurs. So don't write like this. So for example, zinc corrodes minimum at pH 11, but higher at pH more than 11. It corrodes faster. In the case of aluminium, at pH 5.5, it corrodes minimum, but above pH 5.5, it corrodes faster. So pH values of corrosion for metals are different. Next is nature of the ions. If chloride minus ions is present in the solution, it will destroy the protective coating present on the metal and exposing the metal surface for further corrosion. And if silicate is present in the electrolyte, then it will be acting as a barrier for further corrosion. So chlorides destroy the protective coating, silicates acting as the protective coating. And fifth one is conductance of the medium, that is clay and sandy soil. Means what? If clay soil is there, there will be faster corrosion as compared to sandy soil. So faster conduction means there will be movement of the electron fast. So that means there will be corrosion will be fast. So that means higher the conductance, higher will be the corrosion. And last, formation of formation of oxygen concentration cell. So that is earlier we have discussed. That is the one is exposed to the poorly oxygenated part or dilute part, and second is exposed to the highly oxygenated part or concentrated part. The part which is present in the dilute part will be acting as anode, and the part which is present in the concentrated part will be acting as cathode. So anode is going to corrode and cathode is going to protect. So that is called as oxygen concentration cell.